Hi, welcome back to my video demonstrations related to R RStudio. Dealing with data analytics using R RStudio. In my previous video, I explained how to deal with coding and editing, and in this video, I'm going to show you how to perform statistical tests. With this topic, we are actually entering into an area of operations called predictive analytics. And the starting point for the predictive analytics is the probability theory and the probability theoretical distributions and probability distributions. Now, the statistical inference is actually, as I said, the starting point for the predictive analytics. Deals with a particular topic called hypothesis testing. Now, inference literally means testing an assumption that whether it is attributable to a particular population or not. Whenever you have some data just like this is just a sample data. It's not possible for us to have, if you have the total population data, you are lucky and fortunate to have such a fortunate to be in such a situation, but most of the time we don't collect the data related to the entire population. That is not going to be the meaningful activity. Mostly we collect sample data and we try to create assumptions, make assumptions, and each assumption will be verified or evaluated using a hypothesis, and it is referred to hypothesis testing. And to test a hypothesis, we have dozens and dozens of statistical tests. And please be mindful that the inference is actually the testing an assumption so as to attribute that the same assumption is also applicable in the population or not. In this video, I'm going to show you how to perform chi-square test, because we have a data set in which we have categorical data. This data set corresponds to 15 individuals, behavioral attributes of 15 individuals. We have both socioeconomic characteristics as well as study characteristics. Now, I'm going to imagine that we are just going to verify a particular assumption that the satisfaction depends on gender. Usually we refer this situation as intergender differences to satisfaction, something like that, but we are yet to enter into such a costly statements. First, let us start with very basic assumption that satisfaction and gender, both of them are interdependent, something like that. Independent or dependent kind of situation. Like satisfaction depends on gender, gender depends on, obviously gender does not depend on satisfaction, and satisfaction might depend on gender. We are yet to make the assumption that intergender differences are significant or not. That we are going to deal later, but for now let us start with very basic assumption that there is dependability between gender and satisfaction. Whenever I create such a statement, it is going to be the alternative hypothesis. If you don't know what is hypothesis, then you need to study what is hypothesis, what are the different types of hypothesis in statistical analysis. Now, given such an assumption that there is some dependability between these two variables, that is gender and satisfaction, we arrived at a situation that we are trying to test the dependability. Now, our alternative hypothesis is going to be that the variables under study are dependent, and the null hypothesis is going to be variables under study are independent. Why I am trying to create this assumption? Because knowingly that I have categorical data in my hand, I need to choose a particular technique called chi-square test. Because I have assumption in my hand, in order to test that assumption, I need to choose a particular statistical test. And in this situation, in this scenario or in this context, since I have some categorical data, I cannot afford to have any test whichever I think of having for this analysis. I just need to be very precise in selecting the test, since I have the categorical data in my hand. So I need to go for a chi-square test. Now, how to perform this chi-square test inside RStudio? So that is what is going to be the question for this demonstration. Now I have my data inside RStudio. This is the same data which I have in this Excel file. Now we are going to perform the chi-square test between these two questions. The first question is the gender. What is your gender? Something like that. And what is your... This is one of the questions related to a factor satisfaction. There are three questions. Three questions represent this factor satisfaction. Now, how to... Let us get the data, do both of the variables out of this data set. My data, there are different ways to do that. I can do this. I have the gender information, my data, and then sat1 here. But since we are going to perform some numerical analysis, we need to have some intrinsic value inside these data variables. Suppose if I use type of my data, the list is not amenable for data analysis in RStudio. We need to have some integer or double kind of thing. Integer means integer data which has some numeric value inside of the variable. Now same thing if I perform for sat. This to list, so lists cannot be used for numerical analysis. We somehow have to figure out how to get the numeric data. It is not exactly numeric, but some kind of intrinsic value. Now there is another method called indexing. This gender information is column number 1. You see now it is integer. Now you see the sat1 is column number 5. It is integer. Now this is not the appropriate way to use data for chi-square analysis, because we are just going to perform numerical analysis. We need to figure out a way to get some integer based data, some numeric data. But as such it is not, so for example, if you verify this 5, just because we used indexing, it is not going to be numeric. No, that is altogether a different thing. It is non-numeric. Is it numeric too? Yeah, I think it is numeric. Yeah, it is numeric. Now let us use 1. Is it numeric? No, false. It is not numeric. But we need to have some integer data for numeric analysis. So we can use indexing. So what I just would like to tell you this particular thing, that you cannot use array fashioned notation to use that data for numerical analysis. That is what I am just trying to prove precisely. Now to perform the chi-square test, you have a particular function called chi-square test, and now you can just use this type of notation in order to know what is this chi-square test. Now it is going to take you to the browser. It is going to take a lot of time, and let me cancel. Okay, now you can just do search results. Now no results found. Okay, it's fine. I'm just going to use help sorry, I'm going mad, I think, talking on and on and on. Now you see, you will get the documentation right hand side. You can just press this button in order to read what is chi-square test. This documentation is useful for you to understand how to perform the chi-square test inside RStudio. Anyway, I'm just not going to read each and every statement in this example. I'm just going to perform that straight away inside RStudio. To perform the chi-square test, you need to have some... You should understand the syntax for this chi-square test. You need to provide data, and this data should be a table. That is what I would like to tell you. Now in RStudio, you have a function called table. Now when you use my data, 1, this is the gender information, you will get the frequency table. So this is how you need to convert. If you use my data, this is, I index, it is gender based data, my data, and 5th column is going to be sat1, that is numeric data. Now if you use table, my data, and then 5th variable number 5, then you have a frequency table. Okay, now we can make a table, a composite table for both of these variables. That is going to be table my data 1 and then my data 5. So this is a crosstab or contingency table for both of these variables, gender and satisfaction. Now you need to figure out somehow should be able to make a crosstab, because chi-square test is used at top of the crosstabs or cross tabulation. You can just go online and search for what is a contingency table Wikipedia, you will know what is the chi-square test and how it is used for the contingency tables. Now somehow you need to make a contingency table in order to perform the chi-square test. Now we can straight away go for the chi-square test. I think it is better to use my upper arrow button to walk into the history, and now chi-square, I can just use tab button to autofill the chi-square. Now when I press enter, we'll perform the R will return you back with the chi-square test. Now we are performing a chi-square test over these two variables, gender and satisfaction. The assumption, given the assumption that these two variables are independent, that is null hypothesis, and the alternative hypothesis is going to be they are dependent, something like that. Whether that makes meaning or not, that is a different thing. You can think of using this chi-square test conveniently for your data, but for this data I just thought of using chi-square test to test a hypothesis that there is dependability between satisfaction and gender. Maybe this is not the way I can perform the analysis, but just for the sake of demonstration I can just talk about chi-square test using this data set like this. Now coming back to this output, there is a chi-square value and also a p-value. Now when you look at the p-value, this is less than 0.05, so at 5% confidence level we fail to reject the null hypothesis that both of these variables are independent. So now it is not possible for us to study the dependability between these two variables. We cannot assume that the satisfaction depends on gender by looking at the information given by the R after performing the chi-square test. Now there is a warning message. It simply means that this chi-square approximation may not be excuse me, appropriate, because we have very two less observations for this analysis. There is another test called Fisher's test, which might be convenient for this, suitable for this data. You can just write Fisher's test. Now this time you'll not get the warning message. Now this function will return a p-value. Now when you look at the p-value, which is close to greater than 0.05 and also greater than the p-value given by the chi-square test. So the Fisher's exact test is much more favorable in favor of the null hypothesis compared to the chi-square test, but in both scenarios we failed to reject the null hypothesis, and we don't have sufficient evidence in support of the alternative hypothesis that there is dependability in between these two study variables or data distributions, something like that. So this is how we can perform the chi-square test. I think that is sufficient for this video. In my forthcoming video I'm going to proceed ahead with a few other statistical tests, maybe possibly with t-test or ref test, something like that. So thanks for watching this video. Stay tuned for the new content, and if you like my video, press like buttons and don't forget to subscribe to my video channel. Thanks once again.